Good afternoon, everyone. As Fergus says, I'm Andy Fidler, a Principal Network Architect in BT Technology, and I'm leading BT's technical assessment of DNS over HTTPS. The third time at UKNOF, so this DOE stuff must be really interesting. Back in April, we sort of outlined our initial concerns around the unintended consequences of DNS over HTTPS. Then in September, we shared some thoughts around roadmaps, potential roadmaps for encrypted DNS and proof of concept opportunities. Today I'm pleased to come back to yourselves and share some early findings of our DNS over HTTPS trial, and also on behalf of Nick Lehman for Deutsche Telekom, share some of their thoughts too. Here comes the caveat warning. We've only been doing our trial since the 6th of December, so these findings are very much early, so they may be subject to change, but we were really keen to share them with you and, more importantly, get your feedback. So the first thing is, what is our DOE trial? Well, we've been running it as a small base of test trialists across BT employees. We've also shared it with the industry technical community. It's built and working on Open Exchange Solutions Power DNS capability. It's presently supporting only IPv4, and we're doing that to have parity with our existing broadband offering. And it's only supporting the standardized RFC 848 implementation, so not the JSON API. Currently, we're running it as an open public resolver, so anyone can access it. The reason we're doing this is to get the most out of the test trial. However, if we were to move this to a productized solution, then we might look to make it a closed resolver just for BT broadband customers. We're also planning to shortly enable DNSSEC validation on it. So, what are we seeing as early feedback from trialists? The first one is in terms of setup. So we're seeing that people found the Firefox journey really simple. So that's a thumbs up there in terms of using a simple manual config entry. That worked really well for our trialists. Google Chrome was slightly more problematic because trialists had to use executable flags, but that's because of the experimental nature of Chrome with DOE at the moment, and we understand that should be addressed in their branch 81 version. Next topic is automatic discovery. Now, whilst we welcome these intentions of Google and Mozilla here in terms of their same provider auto-update plans, we believe there's challenges here because that won't work for the majority of our base with current proposals. Because current proposals plan to use an IP address lookup table to say, oh yeah, we see this client is talking to the current DNS provider, and this is their IP address, their public IP address. And then we can look that up to see if we can auto-upgrade to DOE. Now, it works fine if you're using a public IP address, but currently, the vast majority of our customers use BT Home Hubs. And currently, we have a stub resolver on our Home Hubs. And that only allocates a private IP address to the clients. So your clients and your applications aren't going to be able to map that to BT. And it's not just a problem for us. Many other European ISPs have this same issue. So here our clear ask is, the IETF and the new proposed Adaptive DNS Discovery Group needs to very quickly come up with a standardized discovery protocol that works for all. So that's the first main area of feedback. Next one is browsing experience. Generally, our trialists were saying it's a good experience. Couldn't spot much difference between DNS over 53 and DOE. However, I'll come on to share some technical measurements where we actually say there may be extra latency through DOE once you've taken the TLS setup into consideration. Next one is parental controls and malware protection. Both of these are DNS based on the BT solution. I'm pleased to say we were able to test their coexistence of these working with our DNS over HTTPS trial. In terms of industry opportunities here, we welcome the work of Mozilla and Firefox around doing the detection of existing ISPs policies, but we believe there's more to be done here. For example, that detection via canary domains needs to be standardized. The other thing is, at the moment, that detection policy only applies to the automatic entry, the automatic default on uplift. We believe that capability should also apply to custom entry as well. So there's more to do on that. In terms of context awareness, the other thing we spotted is that if you have a close resolver only available when you're on network, if you configure that in your custom entry on your browser, and then you go to off network to, say, a coffee shop Wi-Fi, your browser will still try that DO resolver entry. It will fail and then fall back to DNS over 53. But you're going to get a poor experience with that. So here we're saying industry needs to develop a context-aware discovery protocol. So you can have one setting for broadband, one setting for mobile, and another setting for third-party Wi-Fi. And the last thing is, we called out at previous presentations that many ISPs use DNS redirects to support hub setup and customer support. One of the things we do, again, because we've got that hub stub resolver, if a customer types in hub.home, it quickly presents the home hub GUI page. That works fine if they're using standard DNS. As soon as they move to DO, it breaks it. So here, obviously, we're saying ISPs need to avoid using private domains. So that's from the customer experience side. In terms of loading, as you would expect, because it's a low-key trial, we're only typically seeing a couple of queries per second, peaking out at around 5 queries per second, compared to the many millions we see on our live production platform. So based on this, we've used BlazeMeter, the cloud-hosted solution, to load test the capability. We successfully ran load tests at 200 and 1,000 queries per second, using around 830,000 different URLs. We took the worst case scenario of one lookup per TLS session. So that was our setup. Now on to the results. So the first thing here we did is we looked at the full lookup time. So that's a TLS setup plus a DO. And we took these measurements from a BT broadband line. And deliberately we've looked at the mainstream ISPs doing TLS 1.2 with DO. So ourselves, DT, Comcast as examples. We also did the same measurements with Cloudflare and Google, the cloud providers, who are using TLS 1.3. And these measurements were done using curl. And the key observation we're calling out here is that we believe TLS 1.2 has an additional latency overhead. But we would welcome people's thoughts on that. Then the next measurement we looked at was how does DO compared with DNS over 53? Now there's been lots of papers on this, and many of those papers have said there's no significant difference between the two. But are most of those papers considering it just from a DNS perspective? Here we've looked at it from the end-to-end perspective, covering the TLS setup and the DNS setup. So we've taken measurements using curl for DO, we've used our own Pingu, our own test capability, and we've done DO again using curl. And you can see the difference there, that it's indicating that DO is quite a bit longer. But we're also spotting a bit of difference between our measurements for current DNS over 53, between our own Pingu and curl measurements. And we're not sure if this is because our test probes are fully enabled and okay to support DO, or is it something we're seeing in curl? So we would very much welcome people's thoughts on this. We're also looking shortly to work with Sam Knows to do some benchmark tests on our trialist base, comparing performance against DNS 53 with DO. The last bit on performance is load testing, and this is key to the business case because it will indicate how much extra tin, SOA tin, do we need to factor in into the business case for any productized solution. And the early results from this we're seeing, it seems to be indicating a higher than expected TLS overhead on the server capacity, and we're currently working with our vendors on this. Just a bit more on TLS 1.2 versus TLS 1.3. This should justify our comment that TLS 1.2 adds additional overhead. We've gone through and modelled all the flows, and what we're seeing here is that for TLS 1.2 on HTTP2, we're seeing 6 round trips. Then if we move down to TLS 1.3, we're seeing 5 round trips. And that's just in our logic around the additional overhead on TLS 1.2, and suggesting that TLS 1.3 should be the baseline for DO. But we would very much welcome people's thoughts on this. Are we correct with our assumptions? Have we missed anything? Then we've taken that even further and said, what about quick and HTTP3? And if you go down that route, then can you reduce the number of round trips even further? And will that give you very similar performance compared to DNS over 53? Then back to curl. We fired off a lot of curl tests against the 21 DO providers that we're aware of. And this has highlighted some really interesting variations. And is it suggesting the clear need for the IETF and others to develop best current practice guidelines? So the first one to look at is OCSVP stapling. We seem to be the only one doing that. Now we've done that with the mind of saving the client having to check the status with the CA and also to support in-band authentication. But why are we the only ones on that? Have we missed something? Are people not worried about OCSVP signaling? Is it not a load issue? Or are clients not fully checking the authentication? We'd welcome thoughts on that. Next one to look at is session ID duration. Yes, everyone is using 7,200 seconds, so we're consistent there. But is that the right figure going forward? Because your clients and servers are going to have to hold those artifacts to do that resumption. And as DO scales, is that 7,200 too high? Could you argue it should be 0? What's the ideal value? Then more interesting, look at ticket session. We're down at 300 seconds. Google and Cloudflare are 2 days. Next DNS is 7 days. Why such a variation? Is it the balance here between privacy and user experience and performance? Again, we're throwing that out to industry to comment on. Then look at the cipher choice. And there again, there's variation. So here we're calling out the need for best current practice guidelines. Then we've taken it even further. We've used curl to check the responses to various head requests. And we're seeing variations in the response codes returned. And also we're seeing different listeners. So our question here again is, do we need more BCPs to get that consistency? How are the clients going to handle this variation? And then just the other thing to note here, Cloudflare and NextDNS seem to be the only ones doing the DO JSON response code at the moment. Next one's another interesting one, cookies. We spotted something on cookies. We've got a view here is, are user interfaces and policies, are they not totally clear on how cookies are handled across browser and DO databases? For DO domains, we seem to be seeing that the browser side mentions cookies for certain DO domains, and we're seeing that on our own DO domain, and we're potentially seeing it on others, Cloudflare and Google and NextDNS. We assume this is due to visiting the domain, and would hope so, but we would welcome user interface clarity on this, so it's clear which cookies are present in which database, and confirmation that browsers and DO servers are not sending or accepting cookies in DO messages. Do we need further clarification in the IETF BCPs around this? Do we need to make it clear that clients should not accept set cookie as part of a DO response? They should not send cookies, headers that they previously learned from other domains or the relevant domain, and the servers should disregard cookies. The other thing to note, if you look at the Cloudflare domain, it's segmented, cloudflare-dns.com. Why have they done that? Ours isn't. Ours is do.bt.com. Do we need further guidelines around the naming standard? Have Cloudflare done this threaded privacy? So I'm now moving on to present the view from DT on the behalf of Nick Lehman. So Nick's asked me to share here that DT runs a high-performance DNS infrastructure. It's fully redundant, IPv4, IPv6 enabled, they're typically seeing around 2 million DNS requests per second on their platform. In terms of their network architecture, it's very similar to us. You'll see here on the slide, they have a DNS proxy on the hub as well. So they will suffer the same discovery issue that we're finding at the moment. The main difference between the BT and the DT architecture is that we use anycast addressing. They allocate 4 IP addresses, 2 for IPv4 and 2 for IPv6. In terms of the status of the DNS implementation in DT, they've got several different DNS platforms across their mobile and fixed infrastructure. In terms of customer settings, they don't mandate their customers to use their DNS, but interestingly, they've seen that 92% of their customers are using DT's DNS as default, with about the non-DT DNS is 6% traffic to Google, 2% to other DNSs. They're currently only implementing DNS53 due to lack of client implementation from other solutions. In terms of the evolution of DNS at DT, like us, they've started a trial and they're running it with their employees as an internal trial. Again, their solution is based on Power DNS. It's supporting IPv4 and IPv6, and also they're testing DOT as well as DO in parallel. Just some thoughts from DT on the pros and cons of DOT versus DO. Is their preferred solution from a DT perspective is DOT, because they see this as being easier to implement in the home gateway and giving a better experience of managing and providing DNS for all the home devices. The main concerns they have around DO is that they're making it more a complex operational model, the lack of a dynamic discovery at the moment, and also how do you explain the setup journey to customers. In terms of the open issues that DT see for DO, the first thing is, like us, they see that there has to be a discovery mechanism for DO, and they see that as a key item. And within that, they see that you should have the capability that if DO is not supported by a provider, it falls back either to DOT or standard DNS over 53. They also feel it's important to have a series of user cases for DO, especially outlining how the over-the-top DNS is handled. They're also keen for further work around the operational impact of DO. And also they would welcome consideration of DO applications and browsers giving some indication to users that they're using DO or plain text DNS. So now we'll be into conclusions from both a BT and DT perspective. First thing is, it's a good direction that we're in industry at the moment. We're seeing more DO resolvers, more trials and browser support. So it's moving in the good direction. However, many open issues still exist, many of which would benefit from the creation of the proposed new IETF working group. And if I'm honest, that group is still debating the charter, and I think it needs to try and move on because there's lots of questions needed which need to be answered, and the industry is looking to the IETF to address those. So I would encourage people to have a look at the various charter proposals on the ad mailing list at the moment and see if over the next quarter people can reach a consensus on an agreed charter, and then let's move forward with a working group. And to me, the first thing which really needs to be considered by that working group is a standardised DO discovery protocol. And this needs to be context aware in terms of supporting broadband, mobile and Wi-Fi options, and it needs to support all scenarios. And more importantly, it needs to support the scenario where stub proxy resolvers are used in home hubs with private IP addresses. I also think we need best current practice guidelines to address the variations we're seeing in DO and TLS settings. And lastly, I think there's further work needed on the comparison of DO versus DNS over 53 performance and the additional server capacity overhead. Thank you for your time. Any questions?
One question at the front.
Thank you. Andrew Campling, 419 Consulting. One comment, one question. Firstly, just a comment. Andy briefly mentioned the IETF Working Group Charter. Those of you that aren't following it closely, a proposed updated charter was published on the IETF list late yesterday, and it'd be fantastic for people to look at that and, assuming they're comfortable with it, to post their supportive comments. So if anyone's happy to do that, if you haven't got the details, speak to me afterwards. I'll happily provide you with a link to the proposal. And then a question, Andy, you touched on the ISPs with stub resolvers and private IP addresses. Is that something that's common practice for ISPs in the UK and Europe? And
I believe UK and Europe, yes, certainly. I know certainly BT and DT have that issue. I'd welcome if any other ISPs have a comment on that, if the issue applies to them as well. It'd be great to hear that.
Any other comments on that? No, on the stub resolver?
Hi, Tim Chown. Just, I guess, in answer to that point, does it make any difference if you are using IPv6? You then don't have the private addresses? Because you've chosen for some reason not to use IPv6, whereas DT have.
I think we want it's on our roadmap to move to IPv6. The only reason we haven't at the moment is we don't support IPv4 from a DNS perspective on our current broadband solution.
You mean IPv6?
IPv6, yeah.
Okay, I didn't know that.
So it's to maintain parity, but we definitely recognise we want to move to IPv6 on our DNS capability, and it's a roadmap item for the future.
Okay, the other question is something that strikes me as being very applicable to the DOE discovery thing is the provisioning domain work, and I think that's been presented at UKNOF before. The idea of having a specific context delivered through provisioning domains.
Yeah, and this is the thing within
RFC
the IETF.
7556.
Yes, within the IETF, there's around 7 different proposals at the moment around discovery, okay, varying from using the Canary domain, using DHCP, using other solutions. And this is what I think we need to do is bring it into one and identify the best way forward.
Sounds like a good bun fight to be had.
Yeah.
Any more questions? Thank you very much,
Great,
Andy.
thanks.